Hello, welcome. Thank you for clicking through to this video where I'm going to explain the very basic principles, the workings of the valving system on the four-stroke engine and the kind of problems we get when this system fails. Again, this is how these systems work to the best of my knowledge and beliefs, and it's a very basic explanation. There's far more to valving systems than what I'm going to explain. But I really wanted to do this video because we often come across problematic engines and we overlook the valving systems usually as a probable cause.
Okay, so what I'll do, I'll put it all out here diagrammatically and we'll go through it. So to start with then, we'll start with a fuel tank, and then of course we need some fuel, so we've got some fuel in there. And we've got the fuel tank cap there, but down the bottom here we've got a fuel filter. Now I've made it quite large here just to explain my point a bit, and it's not to true scale of course, but we've got a fuel line coming off there. And down the bottom here we've got the carburetor. This is a four-stroke carburetor for now. I'll just explain the four-stroke for now. And then we've got an engine attached to the carburetor. And down here we've got the inlet manifold that allows all the fuel and air to come out of the carburetor into the engine. And it wouldn't normally be this shape. This is more like a cone shape. The reason I've had to do this is because I've had to make the carburetor to a larger scale than it would be for this size of engine, just so I can show what's going on through the carburetor. That's the only reason. So these two here are not to scale. And so we've got all the system now primed with fuel and we're ready to start the engine.
Okay, so how the four-stroke valving system works then? Well, firstly we can see here we've got the inlet valve which is open, and that's because the piston's going down now on the induction stroke. So it's drawing in all of that air and fuel out of the carburetor through the valve and onto the top of the piston. And this valve of course will stay open until the piston reaches the bottom of its induction stroke. At the same time, this valve here, the exhaust valve, remains shut and airtight, because if it wasn't airtight as the piston's lowering, it would obviously pull in air from the exhaust manifold, and that air would interfere with the special mixture of air and fuel that's already in the cylinder that the carburetor created. So it would become more air in there than fuel, and of course that wouldn't combust as well. At the same time, because we're drawing in air here from the exhaust valve, there's going to be less vacuum inside the carburetor here building up to allow the amount of air and fuel to come in at the right quantities at the right time. And so the result there would be, because there isn't the same amount of air being drawn into the carburetor and into the engine, then there won't be the same amount of fuel being drawn out here of the main jet, of course, so there'll be less air and now less fuel because it's the air, the vacuum building up that draws out that fuel. And so of course the engine, if it would run at all, would run very badly. Okay, let's have a look at another scenario here. Let's imagine that we're still on the induction stroke, so the piston's still lowering and we've got the inlet valve that's still open, allowing the air and fuel in to the cylinder on top of the piston, and the exhaust valve is closed and airtight, exactly how we want it to be. The piston then gets to its lowermost point and then wants to come back up onto the compression stroke, because it's got all that air and fuel now, it's compressing it, and as it's on the compression stroke, if we notice now with the valves, both valves are now closed, and that's exactly where we want them to be. Because all of this air and fuel now, this special mixture, it needs to be an airtight cylinder that's containing it so that it can be compressed of course. And needless to say, if there's any leak back from these valves, then it'll be catastrophic for the running of the engine. So as long as they remain airtight, then all well and good. But for instance, if there's any leak back from the inlet valve here, this is the problem we're going to get. We've got all that compression in there ready to combust, but because we've got leak back here with this valve, it goes back through the carburetor and then it would head out towards the air filter, and of course we'd lose the compression inside that cylinder there and the engine wouldn't run. And it's the same here with the exhaust valve. Any leak back here and we're going to lose all of that air and fuel and that compression out into the exhaust there. And so as we've seen now then, any leak back from either of these two valves will lose all of that compression and air of fuel, and it will leave back probably some, but only a substandard amount, and the engine won't run right because we haven't got the same compression in there or the same air and fuel in order for the spark to ignite it and create a combustion situation. Or at least not one sufficiently enough to force that piston down with the intensity it needs to be. Okay, so let's imagine that the valves are doing a good job here. We've got the air and fuel and that compression there at top dead centre there at the uppermost point of the piston, and it's all ready to combust. And upon combustion, let's imagine that some of that explosive material, so some of that fire, is leaking back through one of the valves. And so it's the same sort of scenario then as we had with the compressed fuel and air. We just get that explosive material, so that fire, leaking back through the carburettor if it goes through the inlet valve there, and it's the same with the exhaust here. But in either case, we're going to lose that vital combustion pressure which is necessary to push that piston down at the right pace. And with that combustion being necessary to force that piston down, all we're going to get here is a substandard movement of the piston. It won't actually be forced down to how we need it. And that, of course, will cause a loss of power. That's if the engine runs at all. And so let's take a look at another scenario with the valves then. Let's imagine now we're on the induction stroke again. So the piston's lowering, creating that vacuum. The inlet valve is open and air and fuel is coming out of the carburettor at the right mixture into the cylinder. The exhaust valve is closed, so that's exactly how we want it to be, and we know why now. So the piston goes to its lowermost point, drawing in all that air and fuel, then it rises and it starts to compress that air and fuel till it gets to the top, and then we have power. Now, so far so good, and we can see how the valves there are keeping the pressures inside the cylinder as we've already gone through. And now we're on the exhaust stroke, and we can see now we've got exhaust gases in the cylinder as we've seen before. The piston's now lowering, and the good thing about the exhaust valve is that it opens as the piston's lowering on this stroke. So it doesn't just open as the piston's rising when it wants to force out those exhaust fumes. The reason it opens now is to allow air in so we don't get a vacuum problem. It's actually allowing the piston to lower, else otherwise there'd be a vacuum in there, an airtight vacuum stopping the piston going down. And so this serves two main functions really then. We've just mentioned the first one, allowing the piston to lower, and secondly, as the piston lowers, it brings in some fresh air which mixes with all that exhaust gas, helping to dilute it, ready to be pushed out. And the fact that the exhaust valve's open and the inlet valve here is closed is fantastic, because inside the cylinder here we only want exhaust fumes and air. But if we do take a scenario where the inlet valve's open as the piston's lowering here on the exhaust stroke, then what we'll tend to find is, as well as it pulling through there on the exhaust valve, we'll also have it pulling through on the inlet valve because of that suction, that vacuum that the piston's creating going down. And of course, what's going to happen there? Well, we're going to start drawing air through the carburettor again. And as air comes through the carburettor, some fuel will come with it. And that fuel will go into the cylinder, of course, and mix with the exhaust fumes and air. And then all that's going to happen then is the piston then will come back up on the exhaust stroke and push out all of that unused fuel. And at the same time, because this inlet valve's leaking, it'll most probably leak when the piston comes back up as well. So it'll also force all of that fumes out of this way through the carburettor. So now, going through the carburettor this side, we've got the exhaust fumes, the air and the fuel, and that's just going to mess up everything inside the carburettor, get the carburettor dirty, and as I've said, it's going to cause problems. But to be honest, if there's any major problems with these valves, then the engine won't run right anyway, if at all, as you can see. But at least I've explained now how important that these valves are in running the engine, and how sometimes these can be overlooked as a cause of a problem. Generally we go straight for the carburettor if things aren't running too right, and we forget about the valves. And so I hope you've benefited now about how these valving systems work. Again, it's only a very basic explanation. There's far more to valving systems than what I've just explained, but if I go over the basics like that, at least we can have appreciation and respect for these sort of systems. And in my opinion, when we know things like this, it opens up our minds, if you like. It broadens our horizons to troubleshooting with engines. So I want to thank you so much for watching, and please do like and subscribe if you haven't already done so. Thank you.